I'm conducting the NASA Looking Lab, and I'll be presenting on my recent rotation entitled The Synergism of RMU with Chemotherapeutic Agents to Treat Kidney Cancer and Prostate Cancer. A little background about the Looking Lab. The Looking Lab works on urological cancer research, namely on kidney, prostate, and bladder cancer. Sorry. So we look mainly at the progression of tumors, the utilization of tumor markers for prognosis and diagnosis, and finally, in relation to my work, the utilization of novel therapeutics, namely immune and sulfated HA in the treatment of these three cancers. One of the main focuses in the Lucas Lab is in focusing on the HA-HA system. So what is the HA-HA system? Namely, first, HA. HA is a glycosaminoglycan sugar polymer that is responsible in the extracellular matrix for tissue fluidity and also for cell signaling. At high elevated levels, especially when broken down by HA-ACEs, hyaluronidase, sorry, it's a big tongue twisting over there, it has been associated with tumor metastases. HA synthases, the HASs 1, 2, and 3 family, are transmembrane proteins that have been associated with tumor growth and progression at elevated levels. HA receptors, namely CD44 and RAM, are signaling receptors for HA. Considering the Lucas Lab focuses on therapeutics, one of the main points that we're looking at is to inhibit HA synthesis. Namely, with this compound, 4-methyl-immeliffuran, a very cute compound that is non-toxic, water-soluble, and can be orally administered. It has been proven that that 4-methyl-immeliffuran, 4MU, from now on I'm going to use that word, has been known to inhibit prostate cancer cell growth, motility, and invasion. It has also been shown currently in our lab that in prostate cancer mouse models, no organ or serotoxicity was observed with these mouse models that were treated with 4MU, which I think is pretty cool. And it also downregulates HA receptor expression, namely CD44 and RAM. So, why look at 4MU? Based on a recent study in the BMJ, 20% of patients die from chemotherapy as compared to the cancer they were initially afflicted from. That brings me to my objectives. I have two parts to my project, the kidney cancer project and the prostate cancer project. In the kidney cancer project, we look at microarray data that was previously obtained from treating cells with 4MU in combination with sorafenib, a known chemotherapeutic agent. So why are we treating with both at the same time? Because we hope to lower down the chemotherapeutic agent so as to reduce toxicity. In the prostate cancer project, I did in vitro assays to look at the effects of 4MU and a known chemotherapeutic agent, docetaxel, or also known as Taxotere, in combination. Now, my methodology. For the kidney cancer project, I looked at microarray data that was previously generated from the Phalanx Biotech 26,000 RNA chip that I filtered based on full change p-values that I then plugged into GeneGo for potential pathway identification. Other prostate cancer work, I worked on PC3ML and LNAi cells, which I did in vitro assays for growth cell inhibition, for cell cycle analyses and apoptosis, and finally, qPCR. As for the kidney cancer work, the microarray data, this was so interesting because it was technically kind of in my comfort zone. So I found significant probes based on filtering out whatever data that we have on up and down regulated probes based on full change of anything more than 2 and p-value less than 0.05 to reveal 208, 1,054, 1,580 significant probes, out of which I further filtered for unique probes which revealed in 448 significant unique probes only found in combination. All of these treatments was done in 7860 cells that were treated in combination to 4MU and sorafenib. So why do we want to look at combination? Because we kind of already know what happens in 4MU and sorafenib, but in combination, we want to see what gives the synergistic effect. So upon plugging all the data that I had just now into GeneGo, I generated this differentially expressed heat map, which has two main focuses, or two main trends. The first trend I would like you to see is that we saw a DNA damage regulation. And the second trend is in cell cycle regulation here and here. So this didn't come as much of a surprise, considering that a lot of chemotherapeutic agents out there regulate these cycles, especially cell cycle. So it'll be interesting to look at this further. As for the prostate cancer work, we did on multiple cell lines such as DR145, RNAi, and PC3ML, but we decided to focus on PC3ML work just so that we won't bore you. So for growth inhibition, was the first essay that we did. We titled out multiple concentrations, and we decided to show these concentrations of 4-MU and taxotere for the presentation today. Based on these concentrations, we saw an increase in inhibition, especially in combination. So we wanted to also see, was this an additive effect or was it a synergistic effect? We plugged these values, along with all the other concentrations that we did for this cell line, into a program called Calculising that generated us a CI value of 0.396 that was within our range that indicated the drugs were working in synergism. So, like any chemotherapeutic drug, we wanted to see, was this apoptotic or was it necrotic? We then used, oh, okay, sorry, I had a circle over there. Okay, so we then used cell cycle analyses using flow cytometry to see where were the cells arrested. Uniquely seen was, most of the cells, there was an increase from S phase to G2M arrest observed in combination treatment. Not a surprise again, because chemotherapeutic agents have been known to arrest cells at multiple stages in cell cycle. And we then did an ELISA kit assay where we saw in combination there's almost a 2-fold increase in apoptotic cells. And what exactly happens in the cells in terms of gene regulation? Well, the first thing that we looked at was in the HA system tumor markers such as HAS3 and HIL1. So in HAS3 and HIL1, as you can observe here, there was a major downregulation. So this was not much of a surprise again because it was already published before that HIL1 and HAS3 are downregulated, especially in combination with 4-MU and taxotere. Just one note before I continue, all of the concentrations seen here was as I described before. 4-MU at 0.2 millimolars and taxotere at 1.0 nanomolars, sorry. Okay, moving on. Twist and snail are two transcription factors that we looked at that are responsible or associated with epithelial mesenchymal transition. So these transcription factors were of interest to us, and here, Twist was practically knocked out with combination, so as snail. This was of interest to us, showing that the tumor cells could possibly be halted of its metastatic capabilities. Next, RAM and CD44. If you recall, they are HA receptors. With combination, again, there was a downregulation. Beta-catenin and VEGF, two markers that are associated with angiogenesis, and they are practically knocked out in combination. In conclusion, for the kidney cancer work, we saw that what was differentially expressed was DNA damage repair pathways and the cell cycle arrest. And for the prostate cancer work, we saw that with 4-MU and taxotere, there was indeed adds or synergistic effects. And for future work, what we plan to do with the kidney cancer work would be to focus on these pathways because they were highly regulated, so they would be of much interest. Duh. And for the prostate cancer work, we would love to look at the whole transcript, to look at what's going on as well, like what we did with the kidney cancer work. And then we also would like to look at potential EMT inhibitory effects using assays such as cell invasion, motility, colony formation, blah, 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 and hopefully to use 4-MU for chemotherapy, and also to be used as an oral supplement to treating patients with cancer. And obviously, I would like to thank my family in the lab, especially Dr. Vinata Lokeshwar and Travis Yates. Thank you. Are there any questions?